Good day, students, and welcome to this short, well, I don't know how long this video is going to be, so let's see. But welcome to this video. So what I'm going to do is I'm going to look at your question paper 2, and I'm going to look at some of the questions and just how you should approach studying these questions if you are preparing for your exams. And especially if you are someone that is struggling with a certain topic. Now, what I want to show you is just how you can focus on the basics, and in doing so, you can actually learn a lot and improve your marks quite a bit. So here is what I'm going to send you. I'm going to send you a list of skills that you should be able to do. So what we're going to look at in this video is analytic geometry, and let me show you how you can go about preparing for this subject or for this topic. So I'm going to send you this list here, and here you can see the different topics or the different abilities that you need to be able to do in order to at different levels. So for example, here's grade 10 topics for analytical geometry, grade 11 topics, and grade 12 topics. At grade 12 level, you should be able to do all of these. So obviously the most fundamental thing that you should be able to do are these things in level 1, and then we have level 2 and level 3. Now I'm not going to go all the way up into level 3 necessarily, but if you can do level 1 and 2, level 3 should just follow. So let me show you here what I mean by this. So what we see is, I'll make this smaller. Okay. What we see here, what we should be able to do, change. So the first thing we see here, what we should be able to do is that marks will be awarded, and that if marks are awarded for any formulas, then that is level 1. So when you get the formula correct, then that's a level 1 point awarded. The next level 1 ability I should be able to do is calculating the distance between two coordinates. And I'm sure you know this very well, that the distance formula between two coordinates is the square root of x1 minus x2 minus plus, or that all squared, plus x1, sorry, y1 minus y2. So just the application of this formula is very important for analytical geometry. The next thing is calculating the gradient between two coordinates. So the gradient formula is the next important one, which is y1 minus y2. Does it really matter if they're different way around? And x1 minus x2. As long as these two are the same and those two are the same. Okay, so these two formulas are very important, and their application is level 1. In grade 11, application is finding the midpoint. Okay, so the midpoint is, let's call the midpoint M. The midpoint N would be the average of the x coordinates, so x1 plus x2 divided by 2, and y1 plus y2 over 2. So this would be the average of. Now, the application of these three formulas is usually level 1. In grade 12, what is level 1 in grade 12? Finding the equation of a circle given the center and the radius. In other words, they give you the center. Let's say the center is PQ. Okay, they give you the center PQ, and they give you the radius R. Now they ask you find the equation of a circle on the Cartesian plane, and that you should know. You should know this off by heart. Level 1 means that you know it off by heart. You don't need to think about it. You just know it. So this you need to know off by heart, and that's why we do not give formula sheets until the prelim paper, so that you know these things off by heart. And there it is. It's exactly the same. It's that formula. I'm sorry, I forgot my square there. It's this formula. It's just squared on both sides. And so it's that exact same formula. And so if you have P and Q, you just substitute in there. That's why it's level 1. No thinking necessary. You should know how to do that. That's why it's called knowledge questions. The next is find the coordinate of the center and the radius of a circle from the equation in the standard format. So here's the standard format. Once you have that, you should be able to go both ways with this. Okay, so in other words, you should be able to, given the center and the radius, you should find the equation, and given the equation, you should be able to find the center and the radius. Okay, next, the next level. So once we can this is the basics. This is the basics of analytical geometry. You just need to know all of this off by heart, and you should be able to get 20% of your marks. Okay. Level 2, routine procedures. This time you should calculate the midpoint between two coordinates. Okay, so as you can see here, sometimes in grade 10, what would be in grade 10 a level 2 would be in grade 11 a level 1, and obviously then it's the same. It's a level 1 question in grade 12. So we can already do this component. Okay, identify lines that are parallel and perpendicular based on their gradients. Okay, so you should know the equation of a circle. Y is equal to mx plus c. Okay, and then for parallel lines, that would mean if two lines are parallel, I don't know why it does that. Okay, if two lines are parallel, it would mean that the gradients are equal. Gradient 1 is equal to gradient 2. Then I know lines are parallel. If lines are perpendicular, then you should know that gradient 1 times gradient 2 is equal to -1. Okay, so that should be your knowledge. That's what you should know and be able to apply. Okay, the next point here, and for the grade 11 work, okay, what would be level 2? Finding the equation of a line between 2 points. Okay, so let's change a bit of color. Some excitement going here. Okay, let's say, so now you're given two coordinates. Let's say you're given coordinates A and B, and you're given coordinates C and D. Now they say, given these coordinates, you should be able to find the line that exists between those two coordinates. Now, that should be fairly simple because all you need is the gradient. And then once you have the gradient, you just need the y-intercept, the c value. Okay, how do we find the gradient? Well, we have the formula for the gradient. So we already know how to do that. And once I have the gradient, all I need to do is substitute the gradient that I got, and then substitute x and y with one of these 2 points. And once I have that, I just solve c, and then I get c. So that's fairly easy, but you should be able to know how to do that. Next thing is find the equation of a line through 1 point and parallel to a given line. So now what they give me is, instead of giving me 2 points, they give me a 1 point, and they tell me that the line that goes through this point is parallel to another line. And then we know, well, if a line is parallel to another line, it means their gradients are equal. So instead of having to calculate the gradient, I'm already given the gradient because it's parallel to another line. Lines that are parallel have the same gradients. And then the next thing is find the equation. Well, just to finish that thought, to calculate that equation of that line is exactly the same because I already have m. Now I just substitute x and y with the point that was given. Okay. Find the equation of a line through 1 point perpendicular to the other line. Well, that is again applying the equation of a line. This time I must just find the gradient that is perpendicular. And an easy way to do that is just to flip. If one gradient is 1/2, the other gradient would be a different sign, negative, because I must multiply and get negative. So one must be positive, one must be negative, and then -1. To get 1, I multiply with a reciprocal 2/1. So it will always be like that. If the one gradient is 4, the other one will be -4, 1/4. The one gradient is 2/3, the other gradient will be -3/2. That's when gradients will be perpendicular. Now, again, same thing applies. I've got the gradient. Now I just substitute a point. Now this is the basics. If I know the basics, level 3 is just applying this in a little bit unique context. That is then now find the inclination angle of a line. Okay, here's another point added, and this time I'm finding the inclination angle. So tan theta is equal to the gradient. Now, when I have that, and let me just move this a little bit. When I actually have that, it means that in my Cartesian plane, if I have an angle, the angle that I make with the positive x-axis, the axis that goes east, that angle is theta. And so when I take tan theta, tan of that angle, I get the gradient. Okay, so in other words, if I take theta by itself, it's arctan of the gradient. Arctan of the gradient. That gives me this angle. Now, if it's going to be negative, it's obviously going to be that angle, but or rather, if the gradient is negative, so let's say it's something like this. Oh, sorry. The gradient is negative. So let's say it's something like this. That would have a negative gradient. Okay. Then you're going to get this angle. It's going to give you a negative answer. So it's going to give you this gradient, which is anti-clockwise. No, clockwise. This is anti-clockwise. Okay. So that is what this little formula gives you. And so level 2 at grade 10 level requires you to find the inclination angle of a line. Now, you could, if you wanted to have this angle now, obviously just take 180 minus the angle that you calculated. So that would be the inclination angle, the positive value that it makes with a positive x-axis. And what you also should be able to find the inclination angle of the line between 2 points. So they give you two points. 2 points, and they ask you what's the inclination angle. That's the same. Just work out the gradient and apply this formula to it. And these are the basics up until grade 11. And now for grade 12, find the equation of a circle given the center and a coordinate on the circumference. Okay, so that is an ability that I should be able to do. So let's quickly see what do they mean by that. Let's change color again. Okay. So they say, they give us a circle and they give us the center. So we have R. And then they give us a point. Sorry, not R, we've got the center. They give us a point here, X, let's call that AB. Okay. Given that, find the equation of a circle. Now, what you should know, level 1, what you should know off by heart is, okay, I need the equation of a circle, so I need, let's do it correct, we need x minus p squared plus y minus q squared is equal to r squared. This is what you should know off by heart. And what I already have is p and q because they said they gave me the center. So now I need r, I need the radius. I need the radius, which means the distance between those 2 points. But I have these 2 points. So I've got P and Q already. So I just need to calculate that. And I use the distance formula for that. So look how easy that is. If I know my work, I know how to do the rest. Find the coordinates of the center and the radius from the equation of a circle that is not in standard format. Oh, wow. What do they mean by that? Well, they mean by that if I multiply this out, like let me quickly show you. If I multiply this out, I get x squared minus 2p plus p squared plus y squared minus 2q plus q squared is equal to r squared. Now in this, p and q are real numbers. They're normal numbers. And so, sorry, I need an x here and I need an y there. Apologies for that. Now, if I simplify this expression, so I add all the things that can add, what I will be able to add in the end is I can add these values, because P is going to be a number. P and Q and R are going to be numbers. So I can add them all up. So I will be able to have an expression that looks like this: x squared minus 2p. And 2p is also going to be a number like let's say 10. X plus y squared minus, and then 2q is also going to be a number like, let's say 2. That just means q is equal to 1. Yeah, y squared is equal to r. And then on this side, I'm going to, all of these things are going to add together, and let's call that number, let's call it, I'm trying to do something with its s. Okay, let's call it s. So when I add all of these numbers, I get s. So this is not standard format. So what if they gave me this format? And now I have to get the center and the radius, but this is all they gave me. This. Now let me give you just an example. I'm not going to do it. I'm just going to show you what I mean. So let's say they give me x squared minus 8x plus y squared plus 2. Y is equal to 14. What if they give me something like that? Well, if they give me something like that, I need to be able to go from here into that format. And in order to do that, I must complete the square. So that's something you have to be able to do, is to complete the square. So if you don't know how to do that, you have to go learn how to do that. Completing the square. That's what you need to do there. Right? So that's another thing you should be able to do. Find the intersection of a line with a circle. Okay, that's another thing that I should be able to do. Find the intersection points of a line with a circle. So I don't know if I'm going to have space here. Okay, so if I have a circle, if I have a circle, I have a line intersecting that circle, then I obviously need to be able to find the coordinate points. Now, when I have a line, I have something like this: y is equal to mx plus c, and this circle has an equation like that. Okay, and so all I need to do is replace the y value in here with whatever expression I have on this side, and that just makes an equation. It's just a quadratic equation, and so that's what I need to be able to do. That's what I should be able to do, finding the intersection, the coordinates from a circle, the intersection of a line with a circle. Next is determine the equation of a tangent line to a circle given a certain point. Okay, so now determine the equation of a tangent line. Let's see if I can do that. Sorry. Okay. Good. So now I need to find the equation of a tangent line. Now what's obviously important here is if I have a circle and I have a tangent line to the circle, sorry, there's not really a tangent line, but it's going to have to do. When I have a tangent line, I know that the radius at that point, the radius is perpendicular to the circle, and so wait, come on. Oh, I'm new to this program and I'm struggling to learn how to use it. Thanks for your patience. Okay, anyway, so there I've got a line. Here's my line. Let's call that line T. It's my tangent, and I know that T is it has a gradient of MT, and this one has a gradient of, let's call it MR. His gradient is MR, and so because they are a tangent lines, gradient is at this point. So this is the point. That's the point PR, the center of the circle. Okay, P and R be real centers, numbers, and this will be the point, let's call it AB. And so I know that I can calculate this gradient. And when I've calculated this gradient, I can then calculate that gradient because MT times MR must be equal to -1. And so what should I be able to do? Let's get back there. I should be able to determine the equation of a tangent to a circle if they give you the center and they give you the point. So they tell you where the center is and they tell you where the point is. So this is given, the center is given, and the point is given, and you have to calculate the center. Excellent. There we have all of the basic things that you should be able to do when you do analytic geometry. So let's just quickly go and see that is level 1 and 2. And if you can do those things, you should be able to do 55% of the topic analytical geometry. Now, it doesn't always work out like that. Sometimes the percentages is a bit more in analytic geometry in the first levels or a bit less, and then trig has a bit more of the other levels. Overall, your question paper is divided up into roughly these proportions. Let's just now look at what would be level 3 complex procedures. So if you have to use analytic geometry calculations to show that a set of coordinates fits the minimum conditions for a certain polygon. So for example, they give you a set of coordinates and they say, show that this is a parallelogram. Now you need to use not just your formulas, but your understanding. You need to think about it. Okay, parallelogram. So for example, a parallelogram is has sides that are parallel, and so if you have to show that opposite sides are parallel and opposite sides have sides of equal length. Okay, so in other words, to show that something is a parallelogram, you can show from let's just look at our information. You have to simply use the knowledge that you already have here. Okay, use the knowledge here. Oh, here you have gradients. The gradients must be equal. So notice how you're combining knowledge. You're combining the knowledge that gradients are equal means parallel lines, and then you show that opposite sides are the same length. Okay, that would show that something is a parallelogram. So that's just an example of using the analytic geometry calculations to show the set of coordinates fits the minimum conditions for a certain polygon. Another thing you should be able to do, that's grade 10 level, is to show that one question or if you use one question that relies on multiple routine procedures. So you first have to calculate the gradient and then the distance, and then you have to use those combinations to answer another question. That would be a level 3 type question. Then in grade 11, if you have to find the angle between two lines that intersect. So just to find the angle between the x-axis, in other words, the inclination angle, you just use the formula. So it's straightforward application. But what if I have to find the angle between two lines? So, oh my. Okay, let's see that again. Yeah, so let's say we have a line and another line. Let's say there we have to find this angle alpha. Okay, so how would I find line alpha? Now, to find line alpha, there's going to be a host of things that you could do. What you can find quite easily is theta, this angle here. And you can also find this angle here, because you can find 4 lines if you know the gradients, this gradient and that gradient. If you know these two gradients, you can find the angle that they make with the positive x-axis, with the east axis. Okay. Oh. And so there we go. We can find those angles fairly easily. Now, if I have those angles, then I can use what I know about geometry. So, for example, in geometry, I know that that is also alpha because they are corresponding angles. So, not corresponding angles. Rechtstaande hoeke, I can't remember the English just now, but those angles are equal, and these two together gives me that angle. So this is theta 2 and theta 1. So I can see that alpha in this situation, it's going to be different in different situations. It depends on what the situation is. So here I can see that alpha 2 is going to be this big angle, theta 2 minus theta 1. Do you notice? So notice again what makes up level 3 type questions. It is first I have to calculate theta 1 and theta 2. Then I have to use notice that this angle here is equal to that angle there, and that the sum of these two angles are equal to that angle. So it's not complicated. It's not difficult, but it is a step upon a step. And so that's why it's called complex procedures. Because in level 3 is because there is a step upon another step upon another step to get to the final answer. Okay, find the angle between two lines that intersect. And again, the same just applies. Level 3 would always be questions that follow one upon another. Just a common stacked question, if I can call it that, is this specific one. A very common stacked question in grade 12 is when you have to find the equation of a tangent line to a circle that is not in standard form. Okay, so a normal routine procedure will just be to find the equation of a circle. The equation of a tangent line to a circle. Now, but what if they don't give the circle to you in standard form? Or what if they, if you, for example, you don't know the point, the tangent point? What if the tangent point is a circle? Oh, that is a terrible circle. What if the tangent point is like, oh my. What if the tangent point is like here where it intersects? Right there. So you know the center maybe, but it's there at the intersection point. What if that's the tangent point? Well, now if I have to calculate the tangent line, okay, this is the tangent MT x plus c. Now, what if I have to calculate that tangent point? Well, now at least what I do know is that it is the point where this graph intersects the y-axis. How do I get the y-axis? The y-axis is x equal to 0. So substitute that into the circle. So the circle, maybe that was the equation of the circle. Make x equal to 0, or that one rather. Make x equal to 0 and solve for y. And that will give you two y answers, and you know, okay, it should be this y answer. Now I have the tangent point. Once I have the tangent point, then I know, okay, that if I can calculate the gradient here, mr, then this gradient mt would be negative 1 over mr. Okay, so the reciprocal. And so that's how I do it. And then I've got the tangent point. I already know what the y-intercept is. The y-intercept is the same for both the circle and the line because that's the point there. But that's just an example. I'm just showing you an example of possible ways in which they kind of stack these questions. And that's level 3. And then level 4, which is now not shown on here, but level 4 would be a very unusual problem. Level 4 is called problem solving. So it's really questions that you've never seen before, and you just have to apply your creativity to solve that question. So let me just go and show you now, based on that, how that was exactly what these questions were made up out of. So let me just use that so that I can just write right on here and explain to you. So here you can see, determine the coordinates of B. Okay, so what is B? B is the intercept with the y-axis. Okay, so intercept with the y-axis, there is an equation of the graph. All I do is make x equal to 0. Okay, so just here I'm going to make x equal to 0, and 0 minus minus 3 squared plus y minus 4 squared is equal to 18. Oi, it's equal to 18. And then when you ended up solving this equation, you ended up getting that it's either 7 or it's 1. And so b was equal to 0 for an x coordinate and 1 for a y coordinate. Lovely, lovely, easy 4 marks. Now determine the equation of BD. What is BD? BD is the equation of a tangent line to a circle. Now that's exactly what I said, what we should be able to do, find the equation of tangent lines. Now in order to find the equation of a tangent line, I know that y is equal to mtx plus c, okay, and then we need mt. I already have the y coordinate because look, this line cuts there at the y-axis, so I already know that c is equal to 1 because it's the same y coordinate. So all I need is the gradient. Okay, so the gradient of the tangent is, oh come on, is 1 over the gradient of the radius. So I need the gradient of the radius. To get the gradient of the radius, I need the center. Okay, the center we can read off from the graph is 3 and 4. So it's 3, 4. And so all I need to do is find that gradient. So the gradient of the radius, there were other ways to do this, by the way, is 0, 1. So we subtract the y values. So 4 minus 3 is 3. And then we subtract the x values. 3 minus 0 is 3. Now, when you get your answer, just see that it makes sense. Like, okay, is it true that this gradient of the radius is 1? Well, this looks positive. So if you've got a negative answer, you know, okay, wait, I made a mistake. Let me just see where my mistake is. Okay, that means that the gradient of the tangent is equal to 1 over 1. Sorry, that must be a negative. Negative 1 over. So that is equal to negative 1. If this one is 1, this one must be negative 1. And so that's then where I get my answer very easily, that this gradient, this is equal to y is equal to negative x plus negative x, oops, plus 1. No, this is not working. Sorry. There we go. Let's try that again. Negative x plus 1. Okay. There you go. That makes sense, doesn't it? Okay. How about determining the value of alpha? Okay. Do you see how alpha is an angle? Okay. But think in terms of, don't just rush ahead. This is obviously a level 3 question. Okay. Obviously level 3 question. So it's not just going to be a simple apply the formula and just think about it. If it's a level 3 question, it means I just have to think. Okay, let's think about it. First of all, okay, alpha is the angle with this line. I haven't worked with this line yet. I don't have its gradient. Let's just see what they tell me about it. They say this gradient, this line is parallel to that line. Okay, that's helpful. Okay, so at least what I could do, if I know the gradient, and I know this one's gradient is negative 1, I just calculated it. So I know this gradient, this line must also be negative 1. And so what I could calculate using the formula is this angle here, theta. I can calculate theta. And so this theta, if your gradient is 1, you know you're working with a 45-degree angle. So if this would be 45 degrees, so this would be 135. 5 degrees. So a gradient of 1 is 45, a gradient of negative 1 is negative 45. So here at the bottom there's a negative 45. But you can go and calculate that if you wanted to. It's helpful to know these things. But anyway, that's one thing you could have done is do that. But let me just show you something so much simpler. You also know that this is a radius and that's a tangent. So what you could also have done is just said, okay, well, then I know, and please state your reasons, write it out. Okay, AB is perpendicular to BD, a radian perpendicular to the tangent. Okay, if that's 90 degrees and these are parallel lines, then that is 90 degrees. Okay, great. These are two radii. This is a radius and that's a radius, which means that this is also equal to alpha. Okay, and so then you just do inside angles of a triangle. 90 degrees plus 2 alphas must equal 180. And that just calculates alpha. Okay, so it was fairly easy to work out alpha as 45 degrees. So it was not difficult, not at all. So up until this point, there was really no reason why you couldn't have already gotten 50% for question 1. Because this is 16, no, sorry, that's 12, sorry. Almost. Okay, well, 12, 30%, almost 30%, more than 30% of your marks you could have gotten just by getting those first 3 questions. Then, okay, then they tell us that BD is equal to, the length BD is equal to the square root of 7. Now, this was a problem-solving question. So, the point was they say BD and now you want AD. So just draw in AD. Maybe I must just change colors because I'm all over the map here. Okay. So, they tell me they want the length of AD. And if you had filled in your picture, you should have maybe had something like this where you can see that ABD is a 90-degree triangle. And as a result, if you know BD as the square root of 7, you know the radius already because your radius is the square root of 18. Okay, that's the radius squared. So this is the square root of 18. And then you just use Pythagoras to work out this angle. So it was really not complicated, but that was a problem-solving question, okay, where you didn't necessarily know exactly what the next step is to do, but not difficult to get those marks. Okay, let's look at in the next question. In this circle, we have a circle with center M, with a diameter BC is drawn below. And so here the center is the midpoint. It's obviously there. The coordinate of C and B is given. Respect the line AD is tangent. Okay, so AD is tangent to the circle such that AD is perpendicular to the x-axis. So that just tells me it's a vertical line. Calculate the length of BC. Okay, that was super easy. That, as you can see, is a level 1 grade 10 question. So that one is superbly easy. I think everyone got that right. Determine the equation of the circle. Oh, brilliant. I know how to do the equation of a circle. All I need is x minus p squared plus y minus q squared is equal to r squared. So what do I need? I need the center, p and q, and I need the radius squared. Now, I've already got BC, which was calculated. I'm not going to, the BC was calculated as 10. So the radius is equal to, 5 because BD is a diameter. Okay. And then next is I just needed the center point. Now the center point is just the average of x and the average of y. So this center is -5 plus 1. Okay, -5 plus 1 is equal to -4. The average divided by 2 is -2. Average between 5 and -3, add them together, divide by 2, because there's 2. So that's 5 minus 3. When you add together, that's 2 divided by 2 is 1. So that was the center. And I literally just substitute that then. X minus -2 is plus 2 squared plus y minus 1 squared is equal to r squared, which is 5 squared. Okay, determine the equation of the circle. There was another 5 very, very easy points. Give the equation of line AD. Now this This was crazy. I don't know what, people wrote pages and pages upon information, but the equation of a line in general is y is equal to mx plus c. Okay, that's the standard equation of a circle. Okay, and then m is just the gradient. But the problem is that vertical lines is not a y is equal to something. Okay, a vertical line is the one exception, kind of. It's x is equal to something. Okay, because this is an x value here, and x is equal to something. The same thing on this whole line, everything, x is equal to something. A horizontal line would just be like y is equal to, let's say, well, that could be maybe 7. That would be an example of a horizontal line. How am I going to get that? Okay. Does that make sense? So this is going to be x is equal to something. I just need to know what this x value is that is here. Now, it is a tangent line, so I know one thing that I could have maybe done here is just to also just connect those, and then I have a 90-degree angle. I don't know if that would have helped, but the point is just, I just want to know what this x value is. I know what this one is. This one here is -2. I also know that this length here, from here to there, that's a radius. So I know the radius is 5. So that's almost superfluous to see. Okay, well, that means x is equal to -7. Because it is. I don't know how else to say that. Maths is that simple. It really is. Okay, if D lies on the extension of BD, determine the coordinates of D. So it's just saying, okay, whether this BC gets extended, and then it intersects there. So this is literally the point of intersection between the line y is equal to MBC. Oh, this thing is terrible. MBC x plus c, and x is equal to -7. So it's as simple as that. All you're going to do, you already have the x value. So all you're going to do is just work out, get the equation of that line, and then find the coordinates where they intersect. So this is another skill, a basic skill, is just finding the intersections between lines. That's not necessarily under analytical geometry. That's in functions and graphs. So it is a basic skill you should have for maths, is find the intersection between different lines. And all you need to do is substitute. Find the equation of one, find the equation of the other one, and substitute. So here what you would do is you would work out the gradient here. So the gradient is y, the difference between the y values. So the difference here is 8. Okay, the difference there is 8, divided by the difference between the x values. The difference here is 6. Okay, 6. And then it's just that's the gradient. So the gradient is 4/3. And once you have the gradient, 4/3. Once you have the gradient, you just substitute one of those points. So in the end, when you calculated C, it was 17/3. I'm not going to go through all of that just because it's difficult to write them all on this silly platform. But anyway, so once I've calculated that all, then I get y is equal to 4/3x plus 17/3, and then I substitute x with 7, and so you get -7, sorry. Substitute x with -7. So you get -7 times 4 is negative 28 plus 17, so that is negative 11 over 3. And that was the y value. So you have the x value, sorry, that must be a negative. And then when you substitute x, negative 7 in there, you get negative 11 over 3. So that's the coordinate there. It wasn't that complicated, but probably a level 3 question. And finally, a circle. And then they give you a circle. And here we can see the circle is not in standard form. What do I know? Must I be able to do when a circle is not in standard form? Get it into standard form. I must know how to do that. So given that, and R, there's a different circle, they touch each other. The distance between the centers is 7 units. Okay, so here I've got two circles. Oh, difference. So they just touch each other. And then this distance here is 7. Okay. Now they ask me a few questions. Determine the coordinates of the center of circle K. Okay. Remember what I said. If they do give you an equation that's not in simple, in standard form, you should be able to know how to do that. To do that is super simple. You just take whatever is in front of the x that is not squared. So this side is already fine. Whatever is not in front of the y, the non-squared y, you just take that and half it and square it. So what do? You say y squared minus 2y, and then you add half of that squared. Half of 2, negative 2, is negative 1. Squared is 1. And because I add it on this side, okay, I have a choice. Either, well, there's different ways of looking at it, is you've taken a number and you've added it on this side. So obviously, to keep the balance, because this is an equal sign, you have to just take it to the other side as well. Okay, so add it on both sides. That's just the simplest. So in the end, this then just gets factorized into two brackets. So y is negative 1 squared. So I already have that part. Now you will write it out nicely. I'm just scrapping here on the paper. But we then have that this coordinate, the center on this side is, well, it should be x minus p, but it's not plus p, which means p must be minus 1. So that is minus 1. All you can do is just take this and make it equal to 0. And take this and make it equal to 0. So it's 1 comma minus 1. Don't know if that's going to work. Okay. So 1 and minus 1. Great, that's the center. Now they've asked, what is the value of R? Okay, so this one here, what you'll notice here on this side is this becomes 16, isn't it? So the 1's radius squared is 16. So one of the radii is 4. Okay, this one has a radius of 4 because it's 16. So this one's radius is 4. This distance, we said, was 7, which means this one's radius must be 3. So that's that one's radius. Great! That's it.